Well, hello friends. Welcome back to browser hacking. Today we are going to take a look at CSS floating objects, and this is something that I have been postponing dealing with forever because I don't really feel like I understand how floating objects work. So step one today is figuring out sort of how they work and then implementing them in our browser engine, hopefully. So let's start by just making a little test page. We'll call it f.html, which is not a directory, of course. So my understanding of floats is that they sort of drift to the left or right, and then text flows around it. And I don't have a very nuanced understanding of it, so let's just go ahead and make something here, like, I don't know, lefty and righty, maybe? Something like this. Float left, float right, and just give these guys some color, green and width. Height, I don't know. Maybe we'll make this guy a little smaller so we can tell them apart. And then we'll put these guys here, and then we need some lorem ipsum. But I don't know the rest of it, so we're just going to say lorem ipsum over and over. Whatever. So what would this look like in Firefox? This is not exactly what I had in mind. What did I mess up? I guess I thought this guy would float to the right. So already you can see that I don't understand floats. Where did the right one go? He's up there. He's 0 height. Do I have to put something inside of them? Oh. I didn't spell righty right. Okay, well, that explains that. So maybe we'll put lefty and righty inside of these things so that we can see that. So this is all pretty sensible so far. So basically, like, the text has to flow around these things, and what happens if we put a sort of a div with these guys inside of it, and then a new div down here, then they are still floating up here. Okay. So that part is a little bit weird, but I'm sure we can work this out. Okay, and then let's make a couple more. So maybe like lefty 2 and righty 2. What happens if we put these guys further down, like down here? Then they float like that. Okay. So maybe we should have made a class for these things. Floaty. My web development skills are top-notch, as you can tell. It's something that brings me some amusement, that the people who make browser engines are very often quite clueless about making web pages. Wait, what do I actually want to put in that class? I don't know what I was even thinking. Anyway, let's just move forward. So what I really wanted to do was to come up with some different color or something for these guys. So like orange and I don't know, magenta, and maybe shrink these boys a little bit. Something like that. Okay, and let's just put R2, L2 in those guys. Okay, so this seems like a pretty interesting test, and let's see if we can make our engine do this. So this is definitely going to be interesting because I don't know how we're going to deal with it. So currently this is what we get. Not the most correct layout, obviously. So one thing is that we want to, starting out, we want to like get all of these floating elements and just take them out of the flow. So we have is absolutely positioned. Oh, is floating. Oh, okay, is floating. What's that used for? Okay, wait, so we already track whether something is floating or not, but we don't really do anything other than we don't use it as a we ignore it when we are figuring out which preceding sibling to place a block underneath. Looks like that's the only thing we do with floating things. Although looking at this here, it does feel like this guy right here is placed relatively to this guy, although I'm guessing that what we're really seeing here is the fact that these are in separate divs. So if we bring up the inspector here, we can probably see the outline. So we have this div up here with these two boys, and we have this div with these, and then finally the div with the text. So apparently the floating elements here, floating objects, should sort of how to express this? Like they should sort of bubble up to the body, I guess. Or is it that they just they bubble up to the nearest positioned ancestor, perhaps? Let's go and look at the manual. Wait, where are the details for this float? Positioning the float. Okay. So the float property specifies whether a box should float to the left, right, or not at all. It may be set for any element, but only applies to elements that generate boxes that are not absolutely positioned. Sure. But where do they float to? They, let's see. A floating box's outer top may not be higher than the top of its containing block. But why is the... So I feel like the containing block of these floats should be this div, but I'm guessing that it's not. Let's see. Generated boxes act as containing blocks for descendant boxes in general, sure. Details. Blah, 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 blah. Any notes about floats? Notes about floats. this is too much spec language for me. Okay, let's just wing it, and then we can adjust it later if I'm wrong. So, intuitively, I do feel that they get hoisted up to here. So, the way we compute the containing block, let's see, for something that is position absolute, then we look for the nearest ancestor, which is itself, wait, can contain boxes with position absolute. So that is if it is itself non-statically positioned. So I kind of feel like maybe this is where float, maybe these should be here too. So if float is not CSS float, none. Let's see if that is the general right idea. Okay, so now we have yoinked these up a little bit. So let's see. So we still have these divs, but the containing block of lefty and righty is actually going to become, I guess not the body actually, because the body is also statically positioned, so we'll go all the way up to the initial containing block box. Which I'm not completely sure is correct, but at the same time, like, what would be the rule that would move it under body? So if the element's position, I'm just trying to work out here how we determine the containing block of some block. If the element has position absolute, then it's determined in so-and-so way. So I'm just kind of conflating floating with position absolute, but maybe that's incorrect. I just, I guess the reason that I'm conflating those concepts is because both position absolute and floating elements are sort of taken out of the flow, so they don't participate in the normal flow. Although floating elements affect the normal flow more than position absolute elements do. So, okay, let's not overthink it. Let's just roll with, we just say that the containing block of a float is computed the same way as the containing block of an absolutely positioned element. So then what we want to do is I guess we want to put these guys on the right, side and these guys on the left side. So let's see how we do layout currently of these block formatting contexts. So the procedure for a block formatting context, this is all like one block formatting context. that we care about here. And so the procedure is currently that, actually, because it's the initial containing block, we'll go to the special case. And first we compute the width and the height. Of course, the initial containing block is always the width and height of the viewport, so that's easy. And then we lay out all of the children. And then we lay out any positioned descendants. So I think here is where we would do, or actually we need to do the floats before we lay out our children, because the floats will determine how much space is available for the children. So it actually becomes kind of obvious here that if layout mode is default, or wait, no, we always have to do this. Layout floating children, floating descendants, let's say. Okay, and then we'll copy paste layout absolutely positioned descendants and floating descendants instead. Okay. And then we iterate all of the descendants of the context box of this block formatting context, and we just check if box style float is not CSS float none, and the containing block of the box is this guy right here. This iteration style is not efficient, but whatever. Floating descendant. Yeah. Okay. And then we'll need a function for that as well. So floating descendant. So what the heck do we do with our floating descendant? So a bunch of the basics, I guess, are the same as absolutely positioned, like doing all the box model calculations. But then we start to lose the similarities. So we'll just do a little copy paste here for now. And let's see, and then we're computing the X and Y, but we'll do those ourselves. Actually, do we even care about any of those things? We care about the width and the height. So yeah, we care about computing the width and the height and laying out whatever is inside of it. Maybe we'll ignore all the other stuff for now. Yeah, let's just do that for now, and then we gotta place it to the left or to the right. So assert box style float is not float none. Okay, so now we know how wide it is. We've laid out everybody inside of him, and we computed the height. All that's left to do is place it somewhere. So if box style float is CSS float left, should we like add it to a, I guess we could have like a vector of things that we have floated left and things we've floated right. So something like left boxes floated left, left floating boxes. No template named vector. Wow, this is a very bare bones header. Right floating boxes. Okay, I like those. Okay. And then and left floating boxes append box. So the offset of this box, set offset, will be based on, if we already floated something else left, then it has to go on the right of that. So if n left floating boxes is empty, if it's not empty, we have already floated something else left, and x is left floating boxes last. Oh, dang it. How do we figure out... we need his effective offset plus his width. Okay, so we'll do it this way. Auto previous floating buddy. I don't know. I don't want to call it a sibling because it's not necessarily a sibling in the tree sense, right? So previous floating box, let's say. We don't have to get too informal here, but box is better than buddy. Last. All right, so star that. And then previous floating box, effective offset x plus previous floating box width. That's where we'll place the next box. And x, and then y, I guess becomes 0 in this case. Does this make sense? I feel like this makes sense. Okay, so else in the right-handed case, we have to look at the right floating boxes. And yeah, so now it's the person on our right, so we need to put our x at, now we're computing the x of this guy right here. Imagine this guy. So his x value is the x value of his previous floating box minus the width of the current box. Like that. And then we append it. Ooh. Is this sensible? Not exactly sure, but we'll see. Didn't really do what I wanted. All right. So, what is wrong with this? Are we even doing these things at all? Floating descendants. So one thing is we have to stop trying to lay out floating descendants. I think maybe this code runs and everything, but then we overwrite these coordinates because we're not skipping over floating descendants in the normal layout code. So layout, block, level children. It knows that it should not do absolutely position children, but we need to amend this and say if box float is box style float. Wait, don't we have is floating? Is floating. Yeah, that's a thing. Okay. So that's what we should be checking. Yeah. That'll be nicer. Well, should have been doing this the whole time. Yeah, let's try that again. so some progress. Is not quite right, but some things about this are better. So, oh yeah, we're using left here instead of right, so we're looking in the wrong vector. That'll definitely mess us up a little bit, although I think we're still not quite good. So, left and right. This guy needs to be relative to the green here. So okay, so the red and the orange are kind of behaving the right way, right? Like they're supposed to be red first and then orange from left to right. But the green is bogus because it's not starting we're not starting from the right edge. So we got to fix that. And the problem here is that if we don't have any initial previously floating boxes, we need to say x is the width of the containing block. So context box width. So the context box in this case is our containing block. And let's hammer that point home by saying containing block is context box. Oh, minus box width, of course. Of course. Almost there. Because now we were putting the first box so it would stretch out past the right edge of the window. Allah! Okay, so we are finally getting somewhere. Now we have to get the text to flow around these bad boys. So, how do we do that? I guess when we're doing line layout, we need to check, let's see, so if we're laying out this line of text right here, we need to start, not at the start of the containing block, but rather start at past the right edge of any left floating elements that intersect this line. And we need to stop right before the left edge of the most recently right floated element that intersects this line. So we should only use this space right here. Okay, so I think the block formatting context needs to expose the floating boxes. So let's see. Box left floating boxes. Something like this, and then we'll be able to look these guys up. Okay. Yeah, so when we do line layout, basically we compute the available space somewhere. How do we do that? We split into lines, I guess. So normally what we do here is that we just take like the container. So split into lines works this way, that you call split into lines on some kind of layout node that you want to contribute line fragments to a container. And right now we just use the container width. This is the available space variable, and that will basically always use the entire width here. But the trick is that we have to constrain this. So really what we want is the container width for a given y value, and then we can tell it which y value we are splitting for. Does that make sense? Yeah, because then this line here will have a certain y value, right? And then this one will have one, and when we get to this guy right here, using the y value, we'll be able to determine that it intersects this floating element, but not this one. I think that makes sense. So width at y, let's say, or available at y, and do we have to pass in the y? Where do we get the y from? The line boxes know how tall they are. Line boxes have not been placed vertically yet. Okay, that's a bit annoying. So just imagine that we have a y here, but where do we get the y from? Let's see. So when we do inline formatting, first thing we do is split all of the descendants of this block into lines. Sure. So now this would need to keep track of the y value we're currently doing somehow. How does that work in practice? Maybe there's some obvious solution here that I'm missing. So let's see, where do we set the offset of fragments? Here. So we don't actually place fragments vertically until we lay out entire lines. And we don't know how tall each individual line is going to be until we lay it out. I wonder if this means that we have to interleave splitting and layout. I guess you could do that, like you could split one line and then lay out that line, and then split another line and lay out that line. But so the problem is when we're splitting this text here, this entire text blob, currently we only have the available width as an input, right? So we can measure how much text fits on one line, but we are not tracking the y value of the current line that we're on. Okay, so let's do a crappy solution, and then we'll have to come back to this with something more clever. So I think what we'll do now is that we'll just say, we'll just use the CSS line height property and multiply that with the current line index, maybe something like that. I guess that could work. So line height. Yeah, okay, let's try that. So split into lines. And then say available width. Float available width is container width at, or available width at y. Container why can't I reach into it? Line boxes size times yeah, this is really kind of janky, but let's try it. It was very goofy. Just call it line height. All right. So what is available width at y? And to be able to compute this, we actually need a pointer to our formatting context. So I think split into lines, rather than taking a block box, it should take a block formatting context. So let's see. Yeah, so we have to change the definition of this function. That'll be okay. This is probably a healthy change regardless. So let's see, container available width at y. Let's say context available width at y. Okay. Then we can put this in here, available width at y. And yeah, I guess we could do something a little bit like that. So we're in the middle of lines when we're hit testing, basically. but or available with at line index maybe is more expressive, because then we take the awkwardness out of split into lines and we move the awkwardness into the block formatting context at least. That's probably better, so let's do that. Yeah, let's do that at line. Block formatting context. Line index. Okay, cool. And then now we just have to fix all of the implementations of this. But most of these are going to be pretty simple. Okay. Okay, so here is another instance of the available width. So container line boxes size, and replaced box splitting is kind of a mess right now. It's something we need to look at. It definitely feels out of place, but we'll get to that. Okay, so now it's just the text nodes to go. Context. Okay, and then text splitting, auto container is context box. And are we good there? So we never actually implemented available width at line, but that comes now, I guess, after we fix up all the compilation problems. So here we have to pass in the context, which is us. Although he expects a block formatting context, and we are not that. So already kind of bungled that a little bit. But what we can do is we can cast our parent context, because inline formatting context, you never have, like, there's a stack of formatting context, and the root context is never going to be an inline formatting context, because there's always a block parent of any inline context. So we're going to cheese it here and just cast our parent context to a block formatting context. And then we just need available width at line. Although, perhaps I was foolish, like, because splitting is an inline concept, so why do I want a block formatting context for that? Like, what am I... That doesn't actually make sense. So let's go ahead and change that to take an inline formatting context. And then we'll change that. And then some things will not compile, so we have to fix them. But yeah, it is good that that came up actually, because we do want to just pass this. Yeah, I don't know why I was thinking that we have to pass a block formatting context to line splitting. There's that tunnel vision that you can get when you're doing this mechanical refactoring. Block formatting context. Yeah, because it makes more sense that you would have available with that line for an inline formatting context. I think, let's see. Okay, so right now we can simply return the context box width, and things should be working as they always have. And then we can go ahead and tweak it. Ah, come on now. Come on now. So things still work the way they did before, presumably. Yeah. It's just that now we're actually asking the formatting context for the available space, and we give it a line index. So let's go and see if we can use that for something. So let's see, line height. Let's use the line height as we talked about. Okay, and then we have to look at the right edge of the last left floated thing and the left edge of the last right floated thing. So first available x, or let's just say like x is where we can start putting stuff. So if m for left, if parent, we need to get to the parent context. Oh, right. So we have to go to the parent context, because the parent has the floating elements, floating boxes. So this part is a little bit iffy. Let's see. So we'll call that the block formatting context. So we have a non-zero number of left floating boxes, then left is PFC, left floating boxes, last, effective offset x plus width. Okay, and then right is going to be context box width. And we do the same thing for right floating boxes. Except here, the last right is just the x of the last one. Phew, okay. Oh, wait. We need to actually make sure that they intersect. Right, we have to check the y value. So we have to find the first box that actually intersects this y coordinate. So float y is, this is where we get a bit fudgy. Makes me, this is a hack, total hack, since we don't actually know the final vertical position of lines here. Y position, let's say. Okay. Hack guess. Yeah. So let's just iterate through the left floating boxes backwards and say if left floating boxes at I if floating box I don't want the absolute rect, I just want the rect. Wait, how do I get the rect from a box? I have the effective offset and the size, so that's basically the rect that I care about. Let's just do it this way for now. Okay, and then if rect intersects contains vertically y, then it's a hit. Yeah. Wait, what happens if you have like a third one? Now I am getting a bit curious here. So what if you have a third one that's actually large again? Okay, so it doesn't go under. That's at least a relief. Cool. So let's shrink these even further then. Maybe that's too much. All right. So if we hit it, then we have to stop there. So left is guess rect right +1. Yeah. And we break here. And then we do the same thing for the right floating boxes. So the first time we hit one, then we say that right is rect left -1. There's a bunch more nuance to this. I mean, obviously there's more nuance to this, but yeah, that didn't work at all. Wonder if we're even looking at the boxes here, though. Let's see. So I wonder if we have the wrong idea of a block formatting context, because currently I think we create a new block formatting context for each block level element that we enter. So when we lay out this div right here, each one of these divs sort of creates its own block formatting context, and maybe that's the wrong idea. I could imagine that that's causing trouble here. Let's see. Because I recently reorganized all the code to be in terms of formatting contexts, but I did not really tighten properly what it means to establish a block formatting context. So I can show you how we instantiate these things. So when we want to lay out whatever is on the inside of a box, we just look at the type of box, and then if it is a box with block level things inside of it, then we just create a new block formatting context. But I think maybe that's not the right way to do this. Instead, we should maybe we should maybe continue in the context that we have. Which is a bit weird. But it makes sense that this is the region in which floats interact with other elements. Because if we look at this list of situations that create block formatting context, it doesn't say that, at least I'm not parsing out here, that every block creates a new formatting context. Rather, it's more like special situations. So the main problem, like here, we could just like check here if we're supposed to make a new one, then we make a new one. Otherwise, we use the existing one. I guess if if the box needs its own block formatting context. So if needs new block formatting context box. Creates block formatting context. Yeah, that's pretty good. Then we make our own new one. Otherwise, we will run it in this one. The problem is that we cannot retarget this one because each formatting context, currently the way it's made is that we have a context box which is provided when you instantiate a formatting context, but it seems like maybe this idea was a little bit misguided. That's currently how we keep track of the containing block. But so let's see, how would we express this first of all? So static bool creates block formatting context. And then we had a bunch of criteria like the root element. So if it's the initial containing block, true. If it's floating, if it's absolutely positioned, if it's inline block, if it's a table cell, or a table caption. I haven't implemented that yet, so fix me, table caption. Anonymous table cells, block elements for overflow, yeah, so just fix me. Flow root, don't have that one either. What is display flow root? What is that? I guess that is some new thing. The element generates a block element box that establishes a new block formatting context. So it's like an explicitly a way to force a new block formatting context. That's interesting. That is not something I knew about, but I'm sure we'll get to doing that. Do we have display flow root actually? Box style? No, we don't. Okay. Flex items. We don't have any flex stuff yet. I'm just putting these in. Fix me columns. Span. All return false. All right. All right, so what happens if we simply retarget the context box? As a little hack here, so maybe run should take the context box as an input rather than having it be a function of the, or rather than having it be a parameter to the constructor. Maybe you should just say who you're running it on. We could try that. Although, I guess not, just for testing this out, we can, let's just turn this into a pointer and have a way to retarget it. Something like that. And we'll just star. Okay. set context box, set context box, old box. Okay, I feel like this is going to fall apart terribly, but we need to improve this abstraction. Okay, it didn't fall apart terribly, but in fact, it didn't really seem to do much at all. Creates block formatting context. Let's see, reusing current BFC. I mean, we need to be sure that this is a BFC actually. If is block formatting context, or yeah. That's interesting. So are we reusing this BFC at the very least? We are. Okay. So available width at line. Let's see. Lefties. Let's just print out how many lefties and righties we have in the parent block formatting context to see if we are remotely in the right area of thinking here. We are definitely not even getting here. Okay. Available width at line. Oh, because we forgot to do this when we do text node splitting. I only did it for blocks and replaced element. Available width. Here we need the context, available width at line. Line boxes size. Yes. This is slightly awkward. But I think that should do it. Okay, so now we can see that it is actually constraining the available width because the lines are differently long here. Of course, we're not placing them correctly on the x-axis yet, but at least we are constraining the line layout to the available space. So that's progress. Very, very cool. So how on earth do we get these to pop up at the right X? I guess when we actually place the line fragments, let's see, where's the X offset? Right, so the X offset here. So we have to start at an offset. And the offset will be if if BFC left floating boxes is non-empty, then X offset is BFC. No, we gotta do the intersecting thing again. Oh, dang it. Well, we need the logic from up in the other function. Available width at line. Maybe this should extract some kind of a struct with information. What would we want here? Available space for line, or line space after floats. I don't know. Available space info. Space on line for line info. Start X, let's say. Or we can actually call it like left and right. Yeah, that's fine. So let's put that. Wait. So this stuff comes out here, and then we don't need the available width because actually this is just available space for line. Yeah, something like that. And, oh, and we need the context, right, so this, okay, so this, okay, and then info.left, blah, blah, blah. Okay, now we have this information so that when we want to compute the x offset, we can say that the x offset is available space for line for this, and the line index, which we don't have currently, but we can compute. Left. Okay, and then I think this is probably just a matter of we can just do it this way actually. Okay, we're starting to get somewhere. It's still not exactly right, but because we're just bleeding over here, but starting to look very interesting. Whew. Also, what the heck's going on with L3 here? It's definitely not in the right place. So, wait, are we messing those up? Because they were good before, were they not? This needs refactoring. Okay, yeah, so this stuff is in the right place. It's supposed to be at 0, so why does that change when we use the available space for line.left? Because that should be 0. Because the text inside of here should be in its own, it's in an inline formatting context, which has a block formatting context parent, which should be the floating element itself. So there should be no no floating object pushing it to the right. Left is 0 by default, sure. Maybe here we should do this thing we talked about where we do half the line height. Well, okay, so let's not overthink this right now. We can just say so that part's probably fine, but then let's go ahead and short circuit here if does that make sense though? No, because it breaks this thing. Wait, I'm so confused by this. We have to figure out what's going on. So why are we shooting these guys to the left and right so much? Also, like, why do they bleed into here? I feel like the calculation is not... We're missing something, right? Oh, maybe it's the... maybe it's that these are actually supposed to be... Because like they're like right at the edge of the viewport, right? So that doesn't seem right. Because the margin here, it feels like it's actually accounting as if these are further in. So, did I just mess up that containing block thing that we did originally? The containing block here. If I didn't do that, they don't show up at all. Okay. So yeah, we'll probably have to come back to that particular thing, but let's work out why these end up like this. Nearest block ancestor. So really the containing block of a floating thingamajig should be the nearest block ancestor that creates its own block formatting context. Which we don't know how to compute here, but we know in formatting context. So let's publish this helper. And then we can ask it. Something like that. And well, ancestor, and it's not a block box. Either if ancestor is not a box, or if the ancestor does not create a block formatting context. Phew, okay. And then we can say if is floating, return nearest block ancestor that creates a block formatting context. Phew, okay. Let's see how that goes. That didn't really solve it. I was hoping that would be the solution to the fact that it's like touching the left and top edge of the viewport. But now that I think about it, actually, the nearest block ancestor that creates a block formatting context is the initial containing block. So I have probably achieved nothing here, because it's going to be the root element, so the HTML element. Actually, oh, the root element of the document. So it shouldn't be the initial containing block, but rather the root element. So this was wrong. Box, so if it's not anonymous, let's have a way to ask this, is a root element. Box H. Node. So how do we determine if something is the root element? Well, if we are anonymous, which means that we don't have a corresponding element in the DOM, we cannot be the root element. Otherwise, node, or the DOM node, is HTML element. That is, oh no, wait, hold on. Is HTML element. This is how we look this up. And then we need to include that. HTML element. So, because if we look at this page right here, then this guy here, HTML, this is the root element, not the initial containing block, but rather the root element. I was mixing those up. And I'm not sure it actually matters much in this case. Also, why is it not the body though? Because if you look here, like these, we have 8 pixels of margin on the body, so I would expect these floaters here to be in the body elements block formatting context. This is a little bit confusing to me. I'm not sure why it's like that. Wait, why don't you like that? Oh, because it's called HTML : because of the namespace. And we are getting pretty deep into CSS today. Again, I hope that it is possible to follow along. Dang it. So, why are we not drawing these anymore? Block formatting context is floating. Oh, I remember. Layout floating descendants, because I only call layout floating descendants in the layout initial containing block, so I don't call it in the regular block, which is wrong. It needs to go right here, because we have a special shortcut here for the initial containing block, because it behaves a bit differently. Like the width and height are hard-coded to the viewport. Okay, so still not in the right place, but at least I feel a little bit better about the code. So, what is up with these boys though? Let's see. Let's look at the layout tree. So the let's look at L2 for example. L2 is in lefty 2. Lefty 2 is float left. So that should mean that we create a new block formatting context. If it creates one, which if it's floating, it will. But why does it start 200 pixels into it? That's so weird. And what happened with L3? Or here's R2. Starts at 814? Like, where is that even? It's like outside of the screen. What the frick? So the available space computation is definitely screwing up. I guess maybe we're getting a negative number here somehow. Let's see what we are actually computing. Let's see, computed info, lefties, or let's say LR, that we have how many? So, and how much space? I don't know, it's a bit weird, but left floating box's size, right floating box's size, info left, info right, because something here is not the way it's supposed to be. So if we have like a left that is to the right of the right, for example, I guess that would create trouble. Okay, so what's going on here? We have a negative number in the right. That is suspicious. Why is that? Why do we have negative numbers? Wait. So these, I wonder if we are failing to create a new formatting context inside of those, inside of here. Let's see. Layout inside. Are we just messing this up? Let's dump out the node that's causing us to do this. So dump tree, box. So creating new formatting context for HTML, but we're not doing it for those frickin' floaty magotes. Why not? We should be doing it for those boys, but we're not. That is definitely a problem. So layout floating descendant, in which we call layout inside on the box. And then we determine that the box has inline children, which is true, so we don't create a new block formatting context. Okay, all right, so that's definitely a mistake. So I think this needs to be reorganized here, that if it creates a block formatting context, we just have to make one. Return. All right. And then tap. otherwise reuse the current one. Does that make sense? Let's just do an assertion here. Look at that. Starting to look kind of the way it's supposed to. Let's get rid of that printout, which is causing tons of lag. Oh man, my head is full of information right now. But it's starting to come together, although of course we're still going past the edge here, which I don't like. Also, should these bubble up to the body somehow? I'm not sure. Why would they though? Like, what is causing the body here to create a formatting context? What is the computed style? Display, where's the display property? Display block, sure. So, what is the position of body? Static. And what is the overflow of body? Visible. Oh shit, is that why this is happening? Where was that? No, value other than visible in clip. All right. Contain layout. Contain node. Yeah, I don't get it. Because HTML clearly has no margin, so these floaty floats are relative to the body. I guess these are the relevant properties here, so why? Well, if anybody knows the answer, why are these floats relative to the body rather than to the HTML element? I would love to know why. Otherwise, I'm eventually going to figure it out, but maybe not today. So what else? The space issue, right? So why do we allow whole words? Maybe that's just us being stupid, although I feel like we should break here, right? This should be broken. Why is it not broken? Are we not looking at the right information? So let's see. The right edge. So so we go backwards through the right floating boxes. Oh, wait, does that mean that we're starting here and we're breaking? We hit this box every time, maybe. Is that the problem? So do we need to go from the other side? Let's see. Wait. So we're iterating backwards through the right floating boxes. So this is the first right floating box, this is the second, this is the third. So the first one, we compute his rect here, and then we determine that the rect of this box vertically contains the y value we are interested in. And then we say, okay, so info.right is rect.left minus 1. What's wrong with that? What is wrong with that? I mean, you can tell here that the way that they cascade, it kind of shows us that something is going right, but not exactly right. Okay, fine. Let's add those printouts back so we can see what they actually say. So let's see. When we have 3, the available space. I guess these are the last lines. So this is the top. These are the top lines from the start here. So starting at 220 pixels and ending at 535 pixels. And then ending at 555 pixels. Okay, so that's consistent with what we're seeing here, right? Like there's more space available. But are we thinking stupidly about this? Let's get the GIMP here to measure a little bit. Alright, what's going on here? We should make some kind of a ruler in the web engine. So where the heck are we here? This is 536, so let's say 535 pixels is right here. Which means that this is completely accurate. 535. That's like 1 pixel off. And I did -1, actually, so that is completely right. And what about here? Is that 220? That's 220. So the available space that we inform Mr. Line Splittington about is 535 minus 220. Okay. So I'm not sure why, but I'm guessing that we just are not completely responsible with that information somewhere. But I am going to go ahead and commit at this point anyway, because I've been sitting here for quite a while and we have made enough progress that I am happy with it for the time being. Let's just see that we didn't break any of our typical websites. Homepage looks good. Welcome page looks good. Everything is nice and normal. Clickety clack. Yeah. Wonder how Asset 2 is affected. Now that we actually care about floats a little bit. It's definitely changing. There are a bunch of float tests on Acid 2, so it makes sense that it would change. Acid 1 is even more floats. Let's look at that. Oof. Yeah, it's gonna need more work, obviously, but it actually does look a little bit improved, although clearly not completely right. Yeah. All right. This is a bit of a this and that. So let's see. Libraries, libweb. Just adding that is root element. So it's true if the layout node corresponds to HTML. Okay. And then everything just feels so interdependent. Yeah, so of course there's a monster hack in here, which is unfortunate, which is the fact that we're approximating the tested y coordinate based on the line height times the current line index. So that's not going to work if you have lines with, say, like an image on a line or something like that, right? Or an inline block, which makes that line taller, because then our silly multiplication game falls apart. But we needed something here just to make progress, and then we'll have to improve on this. First, slightly naive implementation of CSS Floats. Float boxes can now be floated left or right, which makes text within the same block formatting context flow around them. This implementing this, or we had we were creating way too many block formatting contexts, as it turns out. We don't need one for every new block, but rather there's a set of rules that determines whether a given block creates a new block formatting context. Each BFC keeps track of the floating boxes within it, and inline or IFCs can then query it to compute the amount of bounds of available space. To find the available space for line boxes, there's a huge hack in here where we assume all lines are the exact line height. This making this work with non-uniform line. Vertically non-uniform lines will require some architectural changes. Yeah, okay, so I think that's kind of cool. Let's see, res HTML misc float 1 HTML. I just want to save it as something. Whew. Man, this was a very educational session. And we have definitely not seen the end of floats. We didn't do anything with the clear property, for example, and I'm sure that we have messed up a bunch of things that need refinement, but even so, it is very nice progress. So I'm happy with this. Whew, okay, so this is going to be the end of the video. I would say I'm very impressed if you made it this far, because this got pretty serious there for a while. So thank you very much for sticking it out with me and hanging out. I hope that you saw something interesting, and maybe we learned a thing or two about CSS today. Also, I don't know what's going on here. Definitely need some more tweaks. But yeah, thank you very much for checking it out, and I will see you next time.